So hello everyone, welcome to our channel. So here we are taking one more question asked in the GATE exam. So here they are taking the open loop transfer function of unity feedback system is given by Gs equal to pi into e the power minus 0.25 into s by s. And in Gs plane, the Nyquist plot of the Gs passes through the negative real axis at the point. So basically, if you extend this question like in our block diagram, so GS and this is plus minus, and they are telling that this is a unity feedback system, so HS should be 1. This is my output, this my input reference. Alright, so HS here is a unity. So they are asking about the as we know, we are in case of Nyquist plot, like in a GS plane, we will discuss in upcoming videos more depth in Nyquist plot. So, but here, what's the information we needed? These things like phase crossover frequency is the frequency at which the phase of system should be minus pi radian, and at this frequency Nyquist plot of the system crosses the negative real axis. Like if you draw the typically Nyquist plot and for like second order system, so like that is coming. Okay, so here this will be negative real axis. So for what point it crosses the negative real axis? Okay, all right. So we want this actually like what's the point it crosses the this negative real axis. So we only bother about the phase of this system. Okay, so like how to solve this question, uh, and one more thing like we will explain, like here they given the question GS and we are taking the open loop gain. Okay, so open loop gain GS into HS, this is our system open loop transfer function, so we want this angle. Okay, so first we have to write GS into HS. So what is the value actually for this? Pi into e the power minus 0.25 into s by s. All right, and then pi into e the power minus 0.25 into s by s, and hs into h is equal to 1. It's coming pi into the power minus 0.25 into s by s. Okay, so we want to angle, we have to write in this term also j omega. So pi e the power minus 0.25 into j omega by j omega. All right, so so we want the omega value at which should be angle should be pi. So here this should be pi minus pi, right? Because we want to negative real axis, it should be minus pi. Okay, so here what's the contribution of angle? This 1 by j omega term write the, I am just writing in the radian form. So minus pi by 2, and what is this term, 2 pi j omega. So this term is, angle contribution is minus 0.25 into omega. Okay, so here minus pi equal to minus pi by 2, this term, and minus 0.25 into omega. Okay, so here it coming out pi by 2 is equal to minus 0.25 into omega. Omega is equal to minus pi by 2 into minus 0.25, minus 1 cancel out, pi by 2. Okay, all right. Then minus pi equal to minus pi by 2 minus 2.5. I'm sorry, here it should be pi by 2, not pi by 2, it should be 0.5. So it should be 2 pi, right? Pi by 1 by 2, 2 pi. All right. Then we want to gain, right? So what is the pi e the power minus 2.5 s by s. All right. So here you consider j omega and j omega. So as we know, e the power this type of minus j theta, this gain should be 1, because this will be cos j theta plus j sin theta. If you find out the magnitude, it should be 1, right? Like cos theta plus j sin theta, I found out the gain. So real part of the square plus many part of square under root. Okay, so it should be 1, because as we know, cos square theta plus sin square theta is equal to 1. So pi into 1 by j omega. Omega value is 2 pi. So it should be 0.5, 2 pi. It should be 0.5. So our point should be, because this is real axis, so point it should be minus 0.5 in comma 0j. Okay, so option is A option is correct. Okay, and one more thing I want to action this question, like like if they ask the gain margin, so gain margin here we can also find out, like and this frequency, whatever we calculate the frequency, and this is also this is a phase crossover frequency. Okay, so phase crossover frequency nothing but at which our phase of system should be minus pi or minus 180 degree. Okay, so here what is a gain, gain margin we can also find out here. So 20 log 1 by this gain, you can take absolute value. So 20 log, it should be it should be 2. So what is the value actually? I think this will be 6 dB. Let me calculate. So 20 log 20 into log, so this will be 6 dB. Okay, so formula of gain margin is the magnitude of the reciprocal of magnitude of the j omega h omega. All right, h omega has been, so there is no problem. So this will in decimal get the 2 dB. So 2. If find out in decimal decibel value, it will come the 6 dB because 20 log this magnitude. All right. So this question we can also extend. They also ask the gain margin also. Okay. And if they ask the phase margin, then we can also how to find out the phase margin for this. For this, we need to find out the first gain crossover frequency. So gain crossover frequency here for gain crossover, this magnitude should be 1. All right. So how to find out 1 magnitude, right? So pi into e the power minus 2.5 s by s. So 1, this magnitude already 1 we know. So pi by j omega gc we can say, gain crossover frequency. So here omega gc is coming out the pi. Whatever earlier we calculate this now, this is a phase crossover frequency. Okay, omega pc we can say here. Okay, all right. So here omega gc is equal to pi. Then what is the angle for this contribution? So minus pi by 2 and minus 0.25 omega. All right, and we want at the omega gc. So minus 2.5 minus 2.5 into what is the value? Omega gc. Omega gc value is pi. Okay, so what's the value we get actually? Four, and this will be 2 plus 1. So minus 3 pi by 4. Alright, and then what is the phase margin? Phase margin 180 plus angle of omega gain angle of this function gc at the omega gc. So it get the plus 45 degree, plus 40 or pi by 4. Alright, so here basically this contribution, this minus 0.25 years, this like this term in our control system is called the delay. So basically if you include the delay, this decrease the phase margin. Okay, system has the uh, less we can say relativity, we can say less stable. Like if you system is pi by s and system pi into e the power minus 2.s by s, so this system is more stable because in this case we get the phase margin plus 90 means 90 degree, and if you include this term, for this we get the phase margin is 45. So both system is stable, but relatively this uh, this system is more stable because phase margin is more. All right, so here we have understood that like what's our actual question was there. We find out a, if they extend this question, if they asking that gain margin, we can also find out the gain margin. Okay, so gain margin how much? 6 dB, the reciprocal of this actually. So in decimal get 1 by 2, in decimal we get the 6 dB. If you ask the phase margin is coming 45 degree. All right, we will extend more depth in this topic, Nyquist plot and our stability analysis. Okay, so that's all for this video. Thanks all.